So like I said, this comes from objective 22.2b. If it comes to zero today, you want to make sure that you're paying attention, okay, while we go through this. It says here that we want to solve the quadratic equation by completing the square. We have 4x squared plus 20x equals to 2. And with this problem, it says to complete the square, so that's exactly the method that we are going to do here. It may be able to be solved differently. We're going to see very soon that we have some other options, like the quadratic formula. And that's absolutely something that we can use. We can't factor it though. Okay, you can go through the process of saying we want to subtract 2 and have it equal to 0, then try to go through the process. And honestly, that's what we've done in the past. If we try to get equal 0, right? We're not going to do that here. Okay? What we're going to do is focus on the 4x squared plus 20x. Notice the number is moved to the other side. We are completing the square. So we're going to go straight to the box. I was tempted to have this along with 22.2a become a 0, have them both become a 0, because this is really not all that different. The only thing that's different between 22.2a and 22.2b, you listen, is there's a number out in front here. That's it. Okay, so we set this up much the same way. We have 4x squared here, and on the left side, we don't have a number that doesn't have an x attached to it. So we can't go directly to finding out what this number is. Okay, we can't go directly to it. Now we're going to set up what's similar to like a puzzle. We want it to multiply to something, two terms to add to something. In this case, we have what they need to add to. The number that's attached to the x is 20x. So this is what we want it to add to. We want two things that are exactly the same that are going to add to 20x. 10x. Okay? The only thing that is exactly the same that can add together to get us to 20x is 10x. So those happen to be what our numbers are, and that is because it's a square, they have to be the same. Okay? So 10x and 10x. Now I know these have to also be 10x, which means that when multiplied, you get 100x squared. This part right here, what comes next, is the hardest part of this solve, and what's a little bit different than before. Watch. If I want to know, and if I want to know what this number is, I know it has to, when multiplied by 4x squared, give me 100x squared. What number needs to be here so that it, when multiplied by 4x squared, gives me 100x squared? Yes? 25. Hardest part right there was to know that, 25 times 4x squared gives me the 100x squared. Okay. Then everything else just gets filled out from what we know. We know that this has to be 10x. This has to be 10x. Right? Those are the two terms that added and multiplied to those specific things. What is the GCF of that first row now? The biggest amount I could divide the top row by. Yeah, Jude? 2. Not only 2, but 2x. Perfect. So 2x. And I know 2x times what would give me 4x squared? 2x here. All right. And then 2x times what would give me 10x? 5. 2x times what would give me 10x? Again, another 5. Notice it's basically the same thing, right? 2x and 5, 2x and 5. What I neglected to do, really important that we do when we're completing the square. Notice that here I didn't have a 25, right? I didn't have this part that I was kind of adding to this problem. So I need to add 25 to that right, or to the left side. So now it becomes 4x squared plus 20x plus 25. But if I add it to the left side, I have to be fair. I have to also add it to the right side. So the 2 that's already there plus 25 gives me a total of 27. Not done, nope. Okay, what this allowed me to do now is to factor this left side to the 2x and the 5 and the 2x and the 5 that I came up with there. So then I have 2x plus 5 squared. That's what 2x plus 5 times 2x plus 5 really means. This equals 27. Again, yes, question. 2x plus 5 right here, and then the 2x plus 5 here. Yep. Again, my goal is to find out what x equals, to solve for x. So I take the square root of both sides. Remember that I got to consider the positive square root of 27 and the negative square root of 27. So then I have as two different options, square root of 27, 2x plus 5 equals negative square root 27. Next thing, we subtract 5. So that's 2x equal to square root 27 minus 5. I'll do the same thing to the other one. So 2x equals negative square root 27 over 5. And last step, divide by 2. Can't really see it here, but if I'm dividing the whole side by 2, everything divide by 2. So one answer, x equals the square root of 27 minus 5 divided by 2. And the other answer is x equals negative square root 27 minus 5 divided by 2. These are the exact answers. I have to warn you. Make sure that you're listening. I have to warn you. The answer that they're expecting, and if you don't write, does not look like what's up here. The way that it looks is this. Negative 5 plus 3 square root 3 divided by 2, and negative 5 minus 3 square root 3 over 2. The negative 5s are no different, right? The negative 5 right here, the negative 5 right here. The 2 that we divide by, this part right here is really not different. But instead of square root 27, they have 3 times square root 3. You're considered still right when you put this up here. What you have not yet done is simplified the radical. You won't learn about this until Algebra 2, and I don't expect for you to know in Algebra 1, but it will mark it wrong. So call me over. Do it on paper. Do the quiz on paper so that you don't get marked wrong. Yes?
I have a question.
Yes.
Okay, so like negative or like subtract 5, could you put that?
Yes, you could. Yeah, that's why they have negative 5 minus instead of 3 square root 3 minus 5. Okay, let's look at the last problem here. This one is a little bit less involved. Still the same process. Notice I have the number on the other side. The 65 is on the other side of the equal sign. What I want to do, similar, box, 16x squared, put here. We don't know the bottom right. Should be writing this down right now. Should be writing this down. Should be writing this down. Okay, next thing. Again, I'm working on this bottom one. We need to set up. We have two things that are multiplying to something, two things that are adding to something. We know the piece that it adds to, that's our negative 32x. What are two things that are exactly the same that can be added together to make negative 32x? They both have to be negative. So negative 16 and negative 16. Okay, so then negative 16x and negative 16x would multiply together to make positive. Ooh, I'm not entirely sure. What's 16 times 16?
36.
Yeah. I want to double check with our calculator, right? It equals 256. So 256 x to the second power. Now, again, I want these two things to multiply together to give me the 256x squared. We just got done figuring out what two things multiply by that, right? So it shouldn't be too complicated to know that this number must be 16. Okay. Now we know what we need to add to the left side and also the right side. I need to add 16 to the left side, 16 to the right side. This way we can factor that left-hand side. So I'll rewrite it here as 16x squared minus 32x, oops, not 36, minus 32x plus 16 equals, and 65 plus 16, well, that's 81. Okay, we came up with these two numbers as negative 16x and negative 16x. What's the biggest amount I could divide the top row by? Alexis, yes.
4x.
Okay, bigger.
Oh, 8x.
Bigger.
16.
Yeah, I can divide by a whole 16x. What's written up there, essentially. Okay, that doesn't happen all the time, so don't think that it always does. But you can divide by a whole 16x the top row. And I know 16x times 1x is 16x squared. 16x times negative 1 is negative 16x. And x times negative 16 equals negative 16x. Okay, now I can put down, and actually, if I were to do this, if I were to go through this process, unfortunately, I wouldn't be able to write it as something squared. Right? Two things multiplied together as something squared. It doesn't work to take out the GCF. So we actually have to do something just a tad bit different. What was initially said?
4.
The 4x. Now let's just check and see. If I were to take out a 4x instead, if we get the same thing, okay, I'll put a 4x here. 4x times 4x does give me 16x squared. 4x times negative 4 does give me negative 16x. And 4x times negative 4 does give me negative 16x. So here, now that we have not taking the GCF of the top row, but changing it up just a tad bit in order so that we get something that we can write as squared. Again, this equals 81. So I have factored that left-hand side so that it was a perfect square. Okay, what about what we might do next here? If I want to solve this, we would square roots. Consider both the positive square root of 81 and the negative square root of 81. Wait, what is the square root of 81?
9.
Hey, it's actually something nice. We don't have to worry about leaving the square root in the problem. It's just 9. We do have still two separate problems, so it's still 4x minus 4 equals positive 9, and 4x minus 4 equals negative 9. Still two separate equations. And then we solve them. Much like any other problem that we've done before, I'll add 4 to both sides. That gives me 4x equals 13. Divide by 4. The answer here, or at least one of them, is 13/4. The other one, I add 4. That gives me 4x equals -5. And dividing by 4, you get -5/4. Two answers, 13/4 and -5/4. These problems, they take up a lot of room. They take up a lot of space. Do them on a sheet of paper. Don't do them on the slates and erase. Do them on a sheet of paper.